Hello, so I'm going to record a review for test 3. So this is test 3 practice. This is all posted on D2L right now, and there's also a Pearson version of this if you want to work through that. I've already done all these questions before in a walkthrough video, but I didn't do them all at the same time, and so I figured this would be helpful. And I'm at home. I've got a few minutes free, so I'll do what I can to get this done for the sake of maybe its benefit to you. So let's get started. Find the x values of all points where the function has any relative extrema, and then find the values of any extrema. So basically we're finding x and y points for this function here, and those x and y points are going to be at the maximum and minimum points of this function. So the first thing you should consider is that this is a cubic function and it's a positive x cubed. Positive x cubed functions look like this. And so the first x, or I should say the leftmost x, the x with the smaller number as its value, is where the max is going to be. And the second x, or the x with the largest x value as its number, is going to be where the minimum is, and that'll come into play later when we find our two extrema values. So just to make life a little easier, I'm going to put this over, I'm going to rewrite this and then put it over on kind of the loose leaf section so that I can work it out a little better. Alright. So we're finding the extrema, so the process is always the same. First thing you do is get the derivative. Next thing you do is you set it to 0. Third thing you do is you factor out a common factor. I can see that there's a common factor of 3 here. If you divide each of these coefficients by 3, this is what you get. It's still equal to 0. The thing that allows us to do is basically get rid of that 3, because we're essentially dividing both sides by 3 here. So if you divide out that 3, this is what you get. I suppose I could keep that in there. There's really no harm in that, I guess. This is still 0 on the right. So we have, basically you can get rid of your brackets and you're left with a simplified expression equaling 0. And you want to factor this into two pieces. Because this is a trinomial with a equals 1, it's actually very easy to get the factors for this. It's like product sum. So like the product is -3, that's this piece. You want two numbers that multiply to make that, and add to make -2. And two numbers that suit those conditions are 1 and 3. 1 times 3 is 3, but you need to make one of them negative. If you make the -3, if you make the 3 negative, and the 1 positive, those two things multiplied together do indeed give -3, and added together give -2. This is still equal to 0 though, so it means that either of these, if you get an x value giving 0 for either of those factors, the whole thing is going to be 0. So set them equal to 0 and solve for x. Basically change the sign. That's going to give you the x values that you want. This is x equals 3. Now if you remember a few minutes ago, what I said was the smaller of the x values is going to be our maximum. It's going to be at a relative max, and the bigger one is going to be at our min because of the way that it looks. Like essentially it's kind of like this. Like this max here is at x equals -1, and this min here is at x equals 3, if we imagine kind of like a number line here. -1 and 3. But the thing that the question asks us is it wants the y value for these points. So in order to do that, you're going to put the x value you found back into the original function. So both of these x values, right? So -1 and 3 are going to have to go into this. Now the original function was this one over here. So that's going to now be -1 cubed minus 3 times -1 squared minus 9 times -1 minus 5. And just while I'm at this, I'm going to just put the 3's in for the next one. Sorry, I'm still a little stuffy due to the illness, but not doing too bad for anyone curious. Making it through just fine. So -1 cubed minus 3, and -1 squared minus 9, -1 minus 5. That apparently gives 0. I'm going to have to check that one. And the other ones are, let's see, I'm calculating out this with 3 in it, and I'm doing it on my calculator on the table here. And I got -32. So that kind of checks out. Maybe when x is -1, the y value is probably 0. So when x is -1, the y value is 0. There's lots of different ways to write it. And the other one has a coordinate of 3 and -32. Or in other words, when x is 3, y must be -32. And that checks out. I mean, what I mean is the y value here, this would be a maximum because the 0 is the highest point in the function. You know, -32 is a much smaller y value, so it probably is pretty low. So let's see what the answers would be. Yeah, essentially the answer is written down here, but you want to take the answer that gives you the answer that makes sense. Generally, you're going to erase any of those that are only talking about one maximum or minimum. You have a maximum and a minimum. So it says it has a relative maximum of 0 when x equals -1, and a relative minimum of -32 when x was 3. That's our answers that you'd put in. Now on the test there would be like a drop-down box, but every now and then students had to do a paper version of this test, and maybe on the final exam you'd have to do a paper version. So it's good to know what to put in those boxes. Moving on. The profits of a certain company are based on Q, which is the number of units of product sold. The profit is represented by the following function. So I'm just going to write down this function here, and I'll put it to the side, and we'll solve the question. It's basically the same question again, to be honest. It's just application, and it's a smaller question because it's a quadratic, not a cubic. So what it wants us to do is find Q, where the maximum number is sold, and then find P, the profit at that time. But really it's the same question as before. So P prime, the first derivative, is going to be -4Q plus 64. You're still going to set it to 0 because that's what we do for this. We have a -4Q on the left, and we'll now have a -64 on the right. If you divide out everything that's not Q on the left and keep both sides balanced, you get that Q is 64 over 4, which is 16. So that's our first answer. That's the number of products that would need to be produced to have a maximum profit, but it is not the maximum profit itself. So essentially this is our answer for A. Now our answer for B is going to be what is the profit, which means the profit when Q is 16. So P of 16, profit when Q is 16, is the original equation, not the derivative, but the original equation with Q replaced. So I'm just reading off the top here. That's the first step, right? That's the first equation. And then that will give me, hopefully, a positive number, because if it's a negative, it means we're not making much profit at all. And apparently it's 442, and that's probably in dollars, although it's probably not asked for. So those are our two answers here. I'm going to compare that. Just forget about that then. 16 and 442 is our answers. So the number of Q of units that produces maximum profit is 16, and the maximum profit itself is 442. That's a shorter version of the first question. The first question was a cubic. This number 2 question is a quadratic. And just in case you're wondering what that would look like, you could have noticed that this is a quadratic. It's got a negative in front of the Q term, the Q squared term. Negative quadratics look like this, and so it makes sense that at some point we're going to have a maximum. So it all checks out. Moving on. Number 3, the voltage E of a certain, you'll recognize this question, I'm sure we've seen it many times now. Voltage of a certain thermocouple as a function of the temperature T is given by this expression. If the temperature is increasing at a rate of 3 degrees Celsius per minute, how fast is the voltage increasing when T is 80? So essentially we have our equation, which I'll write down here and probably move somewhere else. And we've got a load of givens here. Temperature is increasing, so dt by d time, d big T over d little t, is 3. We want to know how fast the voltage is increasing. Voltage is E in this case, so dE by dt is our big question mark. And then T, our temperature, is going to be 80 at that time when the stuff is changing, okay? So I'm going to move this over to give me some space. I don't mean to confuse you or anything, it's really just to be able to see it better. So just give me a moment as I rearrange things here. Give you a breather, give you a chance to write it down or something. So this is really what we have, and our givens are as such. And the first thing I'm going to do, by the way, this is a related rates problem, is what we call this, if you've forgotten. And related rates problems relate the rates at which two variables change. So we get the derivative of both sides, you get the derivative of everything, and make sure that you get a rate pop out of this. So on the left, it's going to be dE over dt. On the right, it's going to be 2.600. Get the derivative of t, which is actually dt by little t, dt over d little t, plus 2 comes down and multiplies. In my case, that is 0.016 t, and then you've got your basically t prime popping out of this. So you can think of this as e and think of this as e prime and t prime here if you want to, but I like to write the whole thing. So what we have a question being asked about this, and we have this rate, we have this temperature, and we have that same rate. So essentially you solve the right-hand side, or input everything into the right-hand side, and it'll give you the left-hand side. So this is 3.16. This is T. Be careful, it's not dt. Temperature is 80, and then we're going to multiply it by the rate, which is 3. And if I multiply this out, and again, I'm just going to do this on my calculator here on the table, I've got 11.64, and I think the units, this is voltage, so it's probably voltage per second or so. I can't remember what the units were in the question. Was it seconds or is it minutes? Minutes. So this is voltage per minute, or volts per minute. 11.64 volts per minute is our answer. So hopefully I'm not going too fast. I'm just I've got a little gap in my day here where I can get this done. So trying to get through it as quick as possible, but I probably went through it slower when I did these questions on the assignment. So you can always watch that as well. I'm kind of doing double duty here. Number 4, a plane flying at an altitude of 6 kilometers is at a direct distance this from an airport control tower, where x is the horizontal distance to the tower. The plane's speed is 390 kilometers per hour. How fast is d changing when x is this? So same story as before, essentially. By the way, this test has 3 related rates questions on it. And this is this is number 2 of 3, I suppose. I'm going to put this over here and write down my givens. Hopefully you can still see what the givens would be. I've got them underlined. The speed, which is actually change in x per t, so dx over dt, that's the trickiest part. The speed is 390. X is given as 9.5, and that's all I need. So this is kilometers and kilometers per hour here. I'm looking for how fast is d changing. I'm looking for d big D by dt. So you need to get the derivative. So I'm going to get the derivative of this, which would bring the half down in front, keep the inside the same, reduce the power by 1, and then you need the derivative of the inside, which is 2x, and please don't forget the kind of x prime here. I know some students like to think of it as x prime, but it's a very specific type of prime. It's with respect to time, so it's a good idea to keep it in there as dx by dt. And now I'm going to put in all my givens. So I've been given this, which is the same as this. I also have this. Basically, I'm just going to solve for d by dt. So that's a half with 16.0 plus x squared, that's 9.5 squared. Negative a half times 2 times 9.5 times 390. And this should give me some realistic result for d by dt. dd by dt. I'm going to put it into my calculator, and you should maybe pause the video and see if you can get this to work out yourself, because sometimes the calculator work is the biggest source of error. A lot of students can set it up, but they can't quite make their calculator get the answer that they want. So just make sure you're not one of those students. This is, I think, 7-0. I don't know how many decimal places it asked for. I'm going to go and take a look. So, oh shoot. Speaking of not getting it right, I didn't get the answer right, so I'll compare my answer in a second. I wanted nearest 10, so I suppose it would be 730, but I need to take a look at the question and see what I've done wrong. So let me just zoom in. I'll pause the video not to waste your time, and then I'll figure out what I did wrong. So what I got wrong was exactly what I was saying not to get wrong. I got the calculation wrong. I didn't do anything else wrong. I just literally put it in my calculator incorrectly. So on my calculator, I got 359.4377 or something. And that would go on for a while, but it wants the closest 10, the nearest 10, which is 360. Like, it basically the question that the nearest 10 would be like, is it closer to 350 or is it closer to 360? And it would be closer to 360. And the question was, I suppose, kilometers per hour. But the number was the most important piece. So just goes to show it's pretty easy to make mistakes when you're putting these things in your calculator. Obviously, I made a mistake myself, so, you know, just double check your work. This isn't the longest test that we've done, so you probably will have time in the 2-hour period to check your work over. Number 5. Now I think I've got this pooled, and by pooled, I mean it could be one of 2 questions. Now one of the questions will be possibly about a metal cube or similar, the volume of it, and another one would be related to this pizza pan thing that we talked about before, like a pizza pan or an expanding disk. And really there's 2 equations that you need to know. You need to know the equation of a cube, and for the disk you'd need to know the equation for the area of a circle. So make sure you know those. There's no formula sheet given for test 3. So this question says a metal cube dissolves in acid such that the edge of the cube decreases by 0.3 millimeters per minute. So edge of the cube decreases by this. So that's like d, I don't know what I'm going to call the edge of the cube, maybe just call it x, dx by dt, and that's going to be 0.30. It's going to be negative because it's decreasing. So things, when they get smaller, they go down, which is why we have a negative, and that's millimeters every minute. How fast is the volume of the cube changing? So how fast is the volume of the cube changing? The volume is a very big keyword. It means that we're going to be dealing with the volume of a cube, which is L cubed, or in our case you can call it x cubed. It doesn't really matter. Maybe I'll rewrite this as L just to make life easier. So volume of a cube is the length cubed, the side length cubed. And when the edge is 7.9 millimeters. So basically we want to know how fast is the volume of the cube changing. So we want dV by dt is really what we're solving for, when the edge, L, is 7.9 millimeters. So that was a little bit messy the way that I set it up, but I just want you to be able to grab all the pieces. Essentially, let me set it up from scratch here. Look, we're looking for the volume of a cube, but we're looking for the related rates of that. So you need the volume equation. So the volume equation for a cube. And the things that I wrote down are obviously going to be important for us. The dL by dt, the dV by dt is what we're looking for, and we're given that L is 7.9. So basically, this question falls apart pretty quick as long as you get the derivative of this equation. So the derivative is dV over dt, as usual, kind of like a v prime. If you get the derivative of the right side, it's 3L squared, but don't forget to have the kind of L prime come out of this, which is dL over dt. And hopefully when you look at this, if you got it all set up right, you've got your L, you've got your dL by dt, and really you're just looking for this left side. Just be careful with your negatives in this question. So we've got 3, and we've got 7.90. It's going to square that. And then it's multiplied by dl over dt, which in our case is negative 0.3. And that means our rate will come out as a negative. I'm going to try to be a little more careful with my calculation this time. And it comes out for me to be negative 56.169. I'm just going to pop over for a second and see what it wants. Nearest integer. Integer means whole number, so the nearest whole number would be 56. It's closer to 56 than it is 57, so negative 56. And that makes sense. If the volume is decreasing, so this is meter, I guess millimeters cubed per minute or something like that, it should all be good here. You just, basically you don't need to mess with the units because everything is consistent. For example, this is already millimeters, this is millimeters. So anything that comes out of this expression here is going to pop out an answer that also has millimeters. You're not asked for units, but just in case you're wondering, that's what they would come out to. So negative 56 is our answer. And now we're into unit 6, which is antiderivatives or integration, right? So it just says find an antiderivative. That is a way of saying, you don't need to really worry about c here, just get the integral. So to integrate this, it goes back to a big F. This is 3 on the outside of t to the power 4 over 4 plus 15t. The 15 is a constant, so when you integrate it, it gains a t. And that is probably enough. We could combine these into something nicer, but this is just a multiple choice, so I'm just going to choose the one that has the 3 over 4. So the answer must be C. Number 7, evaluate the following indefinite integral. Simplify your answer completely. So if this is an indefinite integral, we're going to want to include C. And it says simplify your answer completely, which means like any constants and stuff should get simplified. So we're going to integrate this piece. That means we have 18, and it becomes x squared over 2 plus c. Now the simplification here is just making sure that the 18 and the 2, 18 divided by 2 is 9, right? So you've got 9x squared plus c as our final answer. You would put that into the box or whatever you need to do. Moving on to question 8. Evaluate, simplify your answer completely. This is another just basic power rule question. Power rule for integration, not derivatives. And I'll just do it in line here. So the x squared becomes x cubed over 3. The 7x becomes 7x squared all over 2. And the 5 is a constant, it gains the x, and don't forget c. If you forget the c, I'll have to take off at least a half mark and sometimes a mark, depending on the question. But don't forget c and you won't need to worry about it. So, yeah, easy for me to say, but just do your best to remember it. And by the way, this is the same as this. Like, they're the same thing. I would make sure that you got the marks for it on Pearson if you were to write one or the other. So no worries about that. Moving on to question 9 here. Evaluate the following indefinite integral. Simplify your answer completely, which means, again, be careful of constants. Make sure that you simplify all of them. Now this is a power of a half, which means that we're going to just have a little bit of weirdness going on, but it's not a big deal. We're going to have x to the power of 3 over 2, because 1/2 plus 1/2 plus 1 is 3 over 2, and then divide it by 3 over 2 and plus c. But remember that these need to be simplified. We need to get the reciprocal of that. I've done that a few times in class. So it's 2 over 3 pops outside here, and then everything's on one line. The tricky part now is making sure that you deal with this. So 18 times 2 is 36, and 36 divided by 3 is 12. So we're going to get 12 at the end of the day. 12 x to the power of 3 over 2 plus c. Okay. So moving on to question 10. Evaluate the following indefinite integral. Simplify your answer completely. So this question you're going to want to rewrite, unless you're really good at this stuff in your head, but you're going to want to rewrite it as 5 with an x to the power of negative 1/2, because that's really what it is. Square root of x is a power of a half, but if you bring it to the top now, get the reciprocal, it becomes negative. And now we can do the same basic idea as we did for the last question. So this is going to be 5 times x to the power of 1/2, and it's going to have a half on bottom as well, plus a c. And that half on bottom, if we divide by it, it's going to end up giving us 2/1. And we got to simplify those constants. So 5 times 2 is 10, and a power of a half is a root, so that's a root x plus c. And there we're done. Question 11, evaluate the following indefinite integral. Once again, it's basically just a test of if you know how to rewrite the stuff into power form. So that's what I'll do first. The first thing, 5x power 4, nothing needs to change. But the next one, the constant stays on top, but the x joins it by coming up to the top. You get the reciprocal, change the power, and that's with respect to x. So doing it one at a time, this becomes 5x to the power of 5 over 5. And those will cancel. I can see that right away. I'll cancel them now. Minus 4, and then x to the power of -3 over -3, plus c. So what does this give us? This gives us x to the power of 5 plus, because we have negative and a negative here. In other words, we have -4 divided by -3, right? So -4 divided by -3 is going to be plus 4 over 3. And you can keep an x to the power of -3 there. So that's actually perfectly fine if you wanted to leave it like that, although I did say simplify completely. So it would be better to make sure you simplified completely. Which means that the x power -3 goes to the bottom. This is 4 over 3x to the power of 3, which is cubed, plus c. That would be what I expected for that. I probably wouldn't take a mark off if you missed that very last step, but I did say simplify completely, so just be careful. Number 12, the time rate of change of electric current in a circuit is given by the equation below. Find the expression for the current as a function of time if I is 5 when t is 0. So this question is a particular solution question. I believe this question is also in a pool with one other question. Take a look at your assignments if you're not sure which particular solution questions I've given. But I may give this version of the question, and I may give a slightly different version of the question, but they're both particular solution. And what you would need to do, the first step is to integrate it. The second step is to sub in the givens. And that gives us c, to find c, and then the third step is basically to replace c in that integrated expression. So let's do that. The integral of 8t minus 0.4 t cubed with respect to t. This is our function I. So I is going, and it's I because we're basically reversing the derivative. It was di by dt, reverse the derivative, and you get an I. So this gives us, this is 8t squared over 2, so 4, sorry, 4t squared minus 0.4 t power 4 over 4, which is 1 over 10, or 0.1 t power 4. Try that yourself, please. Plus c. And now we need to do our substitutions. So to make it color-coded, I is 5 and t is 0. So I is going to be 5 when t is 0. Looks like this is going to be a very easy part of the question because these go to nothing. And by the way, the I was 5 and the t's were 0. They're related. That means that 5 is c. Or in other words, if it's easier for you to understand it this way, c is 5. So we have these pieces. We have c is this, and the expression is this. And as I've done in class, they come together to give me the final expression. So I is 4t squared minus 0.1 t power 4 plus 5. That's the answer that Pearson wants. So that's the end for question 12. If you need a little more help with particular solution, go back and definitely review the assignment questions I went through, and maybe even go back through the classes if you need a fuller understanding. Alright, number 13. I guess I don't need this anymore. I'll just get it out of the way. Integrate the following expression. Now this one looks tricky, but it has a very big hint here in that we have a power of 6, which probably make it a different color. That's a 6, which is a hint to use U-substitution. The other hint is that if you look at this and get its derivative, you're going to see its derivative right there, which is another very big hint, like I said, for U-substitution. So I'm actually going to rewrite this so I have some space. I'm going to put it over on my loose leaf kind of page over there. Okay, so U-substitution means that I take what's inside the larger power, or the root in some cases, and set that to U. That'll give me, now I got a derivative of this with respect to the x. That's 3x squared, and then solve it for dx, which is just a quick swap. And I usually make it green or something. I'll just make this green. The reason is, I'm going to be replacing this dx with that, and I'm going to be replacing this piece with u. Okay, so I'm just going to rewrite the expression with those things replaced. Notice that the 3x squared did not get replaced, and that's okay because it will get cancelled. 3x squared and 3x squared get cancelled. That leaves us with an expression that only relates to u, which is perfect because that's a very easy power rule. It's just going to be power 7 over 7. U power 7 over 7 plus c. But remember, let me make this clearer. U to the power 7 over 7 plus c. But we didn't start with u, we started with x's. So if you ended here, you would not get full marks. You would have to make sure that you actually show what the u is. So u is x to the power of 3 plus 5. That's going to be power 7 over 7 plus c. I've only got one U-substitution put onto this test. So actually, maybe two. Let me go take a look. This is one of them. That was question 16. Ah, yeah, number 16, which is actually the last question on the test. It would be integrate the expression, try U-substitution by setting this equal to that. So I've pretty much given the plot away, but that's okay. I like to give you a little bit of help where I can. So I'm going to rewrite this, and I'll put it over to the side again. So it says use U-substitution. So this is going to, this is going to be my u. Get its derivative with respect to the variable x. That actually just gives us, like, this whole thing just gives us 8, right? And then solve for dx. That means dx is du over 8. Sorry. Sometimes my sinuses betray me. I'm going to stick that in here, and I'm going to put a u in here. Let's see what it gives us. It's going to give us the integral of this thing. I'm going to keep it as a root for now so you can see me change it. And we have du over 8. So essentially we can rewrite this. The 8 is going to want to come outside. That's going to give us 1 over 8. Because it was in the denominator, it has to stay in the denominator. And I'm going to rewrite this root so that I can integrate it in this step. The order in which you rewrite these things, like the roots, doesn't really matter. You can do it whenever it's convenient for you. But I usually like to leave it to this point. And now I'm going to integrate. So the 1 over 8 is a constant, doesn't affect anything. I'm going to integrate this, which gives me 3 over 2, which gives me a 2 over 3 when I divide, for the same reason as earlier, plus a c, and the only thing left to do is to replace the u, and of course, well, not of course, but you definitely need to simplify this piece. So that would be 2 over 8 times 3, which is 1 over 12 is what it works out to. You can do it in a couple steps if you want. Replacing u gives me 8x plus 3, because again, I didn't start with u's. I started with x stuff. So you got to put that stuff back in, because the U-substitution was just a tool in your toolbox to get you there. And there we go. That's our final answer. All right, so that's the whole practice test gone through. It took me 34 minutes to go through at a pretty brisk pace, and so you can double that time or triple that time, and hopefully you'll still have plenty of time to get it done in 2 hours. I will mention that where this is the last question on the test, it doesn't include any of the assignment questions that relate to definite integrals or areas under the curve. Those will be saved for the final exam, but I'm still going to pull those questions off the assignments, and so the questions on the final exam shouldn't be too much of a surprise. Hopefully, fingers crossed anyway. So that's your review for the test, and I hope that you found it useful. If there's anything that I made a mistake on or you need help with, send me an email, please. I don't mind clarifying. And other than that, good luck on your test on Monday, and hopefully by that point I'll be fully healed and my son will be back to school, and I'll be able to have my final exam review classes next week, starting on the 12th. All right, take care. All the best. See you later.